Hello, everyone, and thank you for joining us for another session in our 2021 Climate Action webinar series. My name is Tom Nelson, AIA, a member of the AIA California Kohut and Kohut Education Subcommittee, and I'll be your moderator for today's segment. As you know, AIA California has developed an in-depth series focused on understanding and implementing the AIA framework for design excellence. This series will run through the end of this year and will feature monthly, hour-long general climate action webinars, as well as 90-minute webinars that dive deeper into technical topics. Additionally, AIA California has partnered with various organizations with like-minded goals to bring bonus content to you in the comfort of your own office, wherever that may find you. As always, all webinar content and additional resources will be available on the AIA California website shortly after each session. A few quick housekeeping reminders before we get started. Today's session qualifies for one AIA HSW learning unit for those watching live, and AIA California staff will report those units for you. The session is also being recorded and will be posted on the AIA California website with additional resources and a PDF of the presentation shortly after the presentation. As a reminder, please use the Q&A function to ask any questions for today's presenter. You can also like a question to move it to the top of the queue. We'll do Q&A at the end. Now on to today's session. All architects have an important role to play in mitigating climate change. The goal of the session is not to make you an expert in energy modeling, but to expand your energy literacy so you can engage in and lead energy discussions with your design teams. This session's content will apply to all types of architectural work, small to large, residential and small commercial buildings, interiors, TI, and whole building, new construction, or renovation. Now I'd like to quickly introduce today's presenter before finally handing things over to him. Tim Kohut is the Director of Sustainable Design with National Community Renaissance, a regional developer builder of affordable housing. Tim works with design teams, construction teams, and subcontractors implementing strategies aimed at high performance and energy efficiency. He is a certified energy analysis, CEA, a home energy rating system, HERS rater, and a Building Performance Institute, BPI, energy analyst. Tim has spent more than 20 years designing, building, and consulting on affordable housing projects throughout Southern California. So take it away, Tim.
Excellent, thanks, Tom. Let me get the share screen going here and we'll jump right in. So to forewarn everybody as I start my own timer to keep me on track, I've got 91 slides here that we're gonna do in an hour, and I've done this presentation a couple times, so I know I can do it. Ask you to hold your questions until the very end or use the chat function. The slides are gonna move quickly, and I'm gonna keep talking as we go through this, but the focus here is really understanding how architects can do more and be more active in the energy modeling process. Before we get started really quickly, just an intro on National Community Renaissance. We are developers and builders of affordable housing. We are a nonprofit organization with nearly 30 years of history in Southern California. We are the 4th largest in the country. I think we're number 2 in the state of California. We have a portfolio that's nearing 100 properties statewide in California, with properties in Texas and Florida as well, and about 10,000 units in California. So we develop, we build, we manage. As soon as we are done building, we actually move in as property managers, and then we provide resident services. So we're kind of in, we're all in. We never get to walk away from our project. So for us to get the energy efficiency and sustainability right is important to us because we inherit what we build. So we want to do it really well. Our commitment to sustainability, we've been building LEED for Homes at National Community Renaissance since the very beginning. I think one of our first projects was actually the LEED for Homes pilot project for the state of California. We are the only nonprofit developer listed as a power builder by the U.S. Green Building Council, a designation reserved for people who are going above and beyond just certifying their buildings LEED. LEED is our standard, and we keep doing LEED to the highest level in the affordable housing industry over and over again. Interesting, National Community Renaissance was the first non-architectural entity to sign on to the AIA 2030 commitment. So while I'm an architect, I work actually on the construction team and I manage the design teams. I get to run all the energy analysis and analysis for our projects. And I use the AIA DDX over and over again. We'll come back to the AIA DDX at the very end of the presentation. But for the moment, what I really want to focus on is energy efficiency, sustainability, energy modeling, and affordable housing. So I call this the secret sauce for affordable housing. Walk you through this, how this works. And we are most active in these California climate zones, 8, 9, 10, and 15. Typically, Southern California, warmer climates. We do have some projects in 7. We do have some in climate zone 6. 7 is San Diego. 6 is coastal Los Angeles County. The secret sauce works in other climates. You might need to, dice it up and add a couple more ingredients if you're in colder climates in Northern California. But we are building zero net energy housing today. And our first C&E projects are actually coming online as part of the 2016 Energy Code in advance of the 2019 Energy Code because we figured out the economics of renewable energy, especially. If it works for us, it can work for anyone. I'm convinced if we can do this in our really tight affordable housing budgets, everybody should be able to do this. So the key to this is trying to give the architectural community the tools they need to really understand the process. Understanding the energy modeling process is really difficult, and it's important because one size doesn't fit all. Some solutions are going to cost more than others. And then if you've ever had to look at the Title 24 report, it can be a bit like reading tea leaves. You really need to know where to look to find out what's going on and understand if you have an accurate model or not. Performance energy modeling is the key to this. You can't just rely on your energy modeler if you don't understand energy modeling, because they'll walk you to the easiest path for them. It might be the most expensive path in some cases. So performance energy modeling allows us to do a lot of trading. I'll cover that in just a bit. Energy modeling should be integrated from the first day. It has to be in this new code. You can't phone it in anymore and do a smog check Title 24 analysis anymore. If you do that, you're really going to be hating life when you get to that point. You're going to be spending money doing expensive things, or you're going to be redesigning. I'm committed to this. Architects can and should be more engaged, and I will tell you over and over again, there's nothing to be afraid of. I tend to do more energy analysis now in the context of affordable housing than actually do architectural design work, but I integrate it into the process where we're actually, we're influencing the way our buildings are designed and how they look. Energy consultants should be welcome, should welcome participation of informed architects. If you have an energy analyst and you get these skills, now you want to start negotiating and really putting your foot down. I call this unlocking your inner engineer, but keep it simple. So we're going to get into this, and I'm going to try to remove some of the mysteries as we go through this. Before we get started, it's always important to have a tool so you understand what you're shooting for. We like to use the XERO Tool from Architecture 2030. The XERO Tool, if you input the specifics of your project, the size, the location, it's going to give you some indication of is it a heating dominated climate? Is it a cooling dominated climate? Here we are in Southern California. Even though it's sunny and warm at this time of year, it's actually still a climate that's dominated by heating. And what this is going to give you is that target, your energy use intensity, your EUI, or in as many refer to it as your PEUI, your predicted energy use intensity. So what we like to do here is establish these targets early on so we know what we're shooting for. If we have a number in mind, we know what we need to do with our building envelope and our energy systems. For this little project, our target energy score would be an EUI of 6, 80% reduction from the 2005 or 2001 RECS database. That's kind of where we're living right now. So where to start with Title 24? Yeah. affordable housing, we have to understand the budget. Everybody does. You have to understand your program, and you have to understand the energy code. These sheets are available from Energy Code ACE. Every time the code cycle comes out, they update these. These are indispensable because they will give you the prescriptive requirements for your energy modeling. And for us, affordable housing for us always means that the budget is tight. First cost is always the most important issue. So we can't just shoot for targets because we're environmentalists or tree huggers. We have to be mindful of our first target implications. Hitting Title 24 compliance is a first requirement for our projects. But then what we like to do is layer on what I call high performance and get this into the realm of cost-contained high performance. There's no value engineering in this process. We call this cost-contained high performance. So understanding performance energy modeling is the key. So I want to take a closer look at that and jump in. Don't feel like you have to read this page. What I do want to do is highlight a couple little points here. If you look at the highlighted area here, it says use compliance software program approved by the Energy Commission, and compliance in the performance energy approaches across all building systems. Yay, that's the key term here, because when you're looking at the energy performance across all building systems, the building envelope, heating and cooling, fan energy, hot water heating, lighting, now you get to spread the analysis across all those, and you get to do a lot of trading. So trading, what do we trade? Let's take a close look. So wall insulation for us is a first consideration, and I'm talking in the context of affordable housing, but this applies to any project that we're looking at. So for a low-rise residential project, 3 stories and less in the 2019 Energy Code, the U value of the wall is 0.048. Okay, and if you remember back to your building science class, or if you do this on a regular basis, you know that the lower the U value, the better. So we like low U's. Okay, so wall construction, what I need to understand is in a framed wall, I'm looking for a U value in most climates of 0.048. And that for me means a 2x6 wall with R21 insulation, which will fit comfortably in that 5.5-inch cavity. And the key here is for us is to get to that 0.048, it requires a layer of continuous rigid insulation on the face of the building. 2x6 and rigid insulation is really expensive. You know, it's $1.50 a square foot. The last time I looked at this about 1.5 years ago, and it's really complicated to install stucco, which we love to use in affordable housing because of its versatility, its durability, and its cost. It's hard to do that over rigid insulation. So we'd like to get out of the rigid insulation game. So what we want to do here is, how about if we go with no rigid insulation? My wall now is would have a U value of 0.069, you know, far away from the 0.048, but I get to trade across all building systems. So if I do that, maybe I could take a look at the HVAC systems. So this wall that we're shooting for as our starting point performs 30% worse than code minimum. I've got to find a way to make that up. Okay, and I have to find a way as the architect to do this before I ask my energy analyst to do this, because he doesn't care. He doesn't know what how much rigid insulation costs. He doesn't know what the project budget is. So really quickly, the Title 24 minimums for HVAC, we're looking at a 14 SEER air conditioning system, seasonal energy efficiency rating. 14 is our prescriptive minimum. The higher the SEER rating, the better the system. So what I'm looking for here are other options beyond 14 SEER, because they do exist. And we really love what the manufacturers, especially Mitsubishi and Fujitsu, are doing with Minisplits. Minisplits, especially the ducted version of the Minisplit, they're small, they're compact, they come in a variety of sizes, and they have SEER ratings, oh my God, of 20 compared to 14. And the beauty of these things, I'll show you in a second, is the variations in sizing is great because I can precisely match the load. Again, SEER rating, seasonal energy efficiency rating, the higher the number, the better. 14 is our minimum, and I'm looking at 20. So these ones are 46% more efficient than my 14 SEERs. So I just did some trading. Wall is 30% poorer performs 30% poorer than the prescriptive minimum, but my HVAC equipment now performs 46% better. Is this enough to make up for my shortcoming? We need to find a way to measure, okay? So the next step in this is HVAC system sizing. I tell people routinely when I talk about affordable housing and high performance that I'm the cheapest guy in the room. I have to be. I get paid to be the cheapest guy in the room, find the best solution for the lowest money. You can ask my kids, they'll agree. I am cheap and I'm good at it. So what we like to do is zero in on the exact sizing of our HVAC systems. This is a table from Fujitsu with their ducted mini splits. The SEER ratings on these ones are equally high as Mitsubishi's. I got 3 choices here, 9,000, 12,000, and 18,000 BTUs. If you remember back to building science or from conversations with your electrical engineer or your mechanical engineer, you know that 12,000 BTUs is a ton. So anywhere from 3/4 ton up to 1.5 tons are their standard sizes. And you're buying HVAC per ton of cooling. So the less you buy, the more the better value you're going to get, especially if it's 40% higher, 40% better than the 14 SEER units. So the mini splits cost more per ton, but because I can precisely match the tonnage to the loads, the calculated loads, and I'll show you how to do that. I can reduce or maintain the cost of my HVAC systems. The Carrier First Co option, which is very popular and still is in some cases, the smallest size that Carrier makes in a non-mini split version is 1.5 tons. So even if you only need 3/4 ton of cooling, your mechanical engineers, if they're still living in the 1990s, as many of them are, will say you get a 1.5 ton system, and you got to push them towards these other options because they're so much better. Let's do some conceptual analysis to test this out. So I've done the trading, or I've at least hypothesized what the trading is. Now I need to figure out how to measure this. So we're going to look at the free tools. Again, I'm a cheap guy. I want the free stuff. I do have some paid tools that I'll show you later on, but the idea is to get the free tools in the hands of the architectural community. Hopefully some of you are very familiar with these, at least some of these. The first tool I like to use is Climate Consultant. This is what I believe to be the indispensable starting point for any conversation, especially when you're jumping from climate to climate. Climate Consultant is free. It's available from energydesignTools.aud.ucla.edu, or just Google Climate Consultant. It's one of the first options that will come up. Input your zip code, and you're off and running, and it will give you some really important information. I like the temperature range graph because I can look at my design highs on the right. That little dot that hovers over the top is telling me the design high for climate zone 10, or the record high that I might want to design to is 103 degrees, and the low is in the low 30s. I also really like the psychrometric chart. Psychrometric chart is 8,760 data points that record dry bulb temperature and relative humidity. And I look at a psychrometric chart. If you look at these over time, you can actually smell the climate. You know when you're in a hot, humid climate, or a hot, dry climate, or a cold and moderate climate. What's nice about Climate Consultant, you can click on this box down in the lower left-hand corner that says locate the best strategies. And from the best strategies, it's going to get you to the next page, which is the design guidelines prioritized in the order of importance. So you can click on these, and what will happen inside of Climate Consultant is it will open up these little guides, which are nice. You know, for architects, it's a little bit rudimentary. But what I really like is the handy link to the 2030 palette. So they were smart enough that the people at UCLA knew and understood what was going on with the 2030 palette. The guys at Architecture 2030 knew what was going on at UCLA. So they created this link. So I can, on this particular strategy, click on the link to the 2030 palette and open this up and get into more technical information and guidance. And inside of the 2030 palette, they'll give you a link to tools. They'll give you some guidance, some technical guidance if you want to study up on this a little bit, if you need to study up. And then from there, you're ready to now take some of these ideas that these conceptual ideas that you want to employ, and take it into one of the tools to measure what you want to do for energy. And I call this process sketching with energy. You're doing this on day one when you're just coming up with these little rectangles and trying to figure out what you want to do, and you want to understand what your climate can do for you. So heat is for single family homes and individual apartment units. I'll go through heat and do a multifamily example for you guys. And what you do with heat, it's really nice. It's sort of like an interview for you. You're going to go through screen by screen, describing what's going on with your climate, your building type, and then the aspects of your building envelope and your energy systems. Heat has been around for 2 previous code cycles. What you're going to see is that it has not been updated for the recent code cycle. So what we're going to do is build as our first option here, the 2019 Energy Code Compliance Scheme. Once we do that, we're going to be able to then copy that and then make adjustments one at a time. So here's what I want to do. We want to simplify this as much as possible, and we're going to do a multifamily project. But I don't need to model the entire building to understand what my envelope and energy systems need to do. I need to start with a simple shoebox. So this is a project that we're building in, I think this is in Santa Ana, 91 units of multifamily housing. And what you see here is I've identified my little top unit on the top that's south facing. So it's going to get south facing sun, and it's going to get heat gains and heat losses through the roof. So this is going to be one of the warmer units that I want to study. So, and this one, I moved it to Rancho Cucamonga just to make a point, which I'll show in just a second. And I'm going to build my little shoebox. I'll show you how I do that. So the first screen you see on heat, you're going to be asked to describe your project. It's a brand new home. It's an apartment or condo. It's entered directly from the outside, double loaded corridors, unconditioned for this project. And like I said, he does a really good job of asking you those questions. Okay. The apartment has 1 story. We're not talking about the building. We're talking about my unit, my shoebox. Okay. So I'm only interested in that unit, and this is a 1-bedroom apartment, 576 square feet. I input my zip code here, 91730 is Rancho Cucamonga, and he knows your California climate zone immediately. So next step, I'm going to land on the floor planner. Each one of these squares is 4 feet by 4 feet. Don't overthink it. We're sketching an energy here. It doesn't need to be precise. We don't need to worry about inches. We don't need to worry even about 1 or 2 foot increments. We want to get the building size in the ballpark. So 4 foot by 4 foot modules are totally fine for understanding what you need to do. So I click and drag across here, and the yellow box is my unit, and the purple boxes are neighboring units, which are also conditioned. So heat is smart enough to know that I'm not going to lose any energy through those walls because my neighbor's going to set their thermostat at 78 degrees. I will lose some energy into the corridor, which I kind of leave as just open. There are no solar gains on the north side, so I'm not really worried about that. I can add other elements here, especially with single family homes. I'll show you some elements later on that render really nicely, but for this one, I'm going to keep it simple. And again, this one, top floor, unit next to other units. Okay, and now what we want to do here is adjust the orientation. So heat is smart enough, once you've done your little sketch of your unit, you can grab the dial of your building and you can move it. Right, so you don't have to describe it and understand, geez, west is 270 degrees from cardinal north, or, southwest is 135. You don't have to understand that stuff. You just grab the dial and twist it, and heat is smart enough to know that it's going to set that orientation for you for the analysis. For this one, we're going to leave it to the south. It is a south-facing unit. And now I'm going to go through the interviewing process. Next stop is my windows. So for this one, I'm on the outside of the building looking at the front. So what we want to do here is describe the size of the windows. You can see with, that front window in the living room is 6.5 feet wide, 6 feet tall. I've got an overhang, on the south side, very important. I'm going to define that, a 5-foot overhang, which is the overhang or could be the balcony above, and it's offset by a foot. I've got a front door that faces into the a front door that faces south, so there's a patio door, and then I've got a rear door that faces into the corridor. If you're looking at this and you have multiple exposures, you're on the outside. So if you're looking at the front, the right side would be the east side. If we had a west-facing windows, it would be on the left side. So if you're looking at the front and your front is facing south, to your left is west, to your right is east. So that's the way you think about this. Okay. What's nice about this is once you've described the size of your windows, the next screen, heat is actually going to drop those things on your curb. And what you're going to do is grab your mouse and you're going to click and drag them onto your building. But don't worry, if you're not, if you don't want to do that part of it, you can leave them on the curb. Heat is smart enough to know that a building on the curb actually should be on that wall. The placement on the wall is unimportant from an energy modeling standpoint. All we're looking at is the relative U value and the solar gains that are going to come through that window. So you could put it anywhere. It doesn't really matter. It won't impact the science of the heat balance equation. Okay, now let's go on and describe the building envelope. We're going to create the 2019 Energy Code scheme, if you remember. Heat is going to give you two schemes to start. It's going to give you your code minimums scheme. In this case, it's the 2013 Energy Code that was last updated in HEAT. And then the second scheme that he's going to give you is the improved scheme. And it's a recommendation that HEAT comes up for you. Then you start building your own schemes based on your footprint and your inputs. So the scheme 3 for us here is going to be the 2019 Energy Code building. So I'm going to try to hit our code minimums on this. The prescriptive minimum for Windows here, as I look through Windows, is a U of 0.3 and an SHGC of 0.23. So I'm going to pick 0.32 and 0.25, and we'll adjust this later. I'll show you how to do that. I click next, and I'm going to land on the screen with insulation. So we're going to zero in on insulation over the course of the next 2 screens. This is the level of insulation for the whole building. So I'm going to set to current code with no radiant barrier for now. Okay. We'll refine that later. And then we're going to move on to walls, which is closely related to the insulation. Prescriptive minimum for walls in climate zone 10. If you remember back on that guidance sheet I showed, it's U equals 0.048. So I'm going to select 0.047, pretty damn close. Good enough for that. We'll refine it later. Going on to the roof. Okay. And this is a top floor unit. So I'm going to say it's a flat roof, which it is. And that's it. From there, I'm going to floors. I'm going to define the floors. We do wood frame, so it's lightweight concrete. We will put carpeted here for now. And there's no heat loss. If you look at the second bullet screen there, it is no heat loss through floor because there's another unit below. So it knows that it's not losing heat to the unit below. Okay, if this were the ground floor unit, you select raised floor or slab on grade. Okay, so just a heads up on that, depending on your project. Infiltration, how leaky is our building? So in the 2019 Energy Code cycle, very similar to the 2016 Energy Code cycle, we have very tight building envelopes. QII is our standard for prescriptive building quality insulation installation put in with care by your installing subcontractor and HERS verified. So I'm going to go with that HERS verified air seal and quality insulation installation. 3 air changes, ACH 50. Ventilation, cooling, there's some great options on this screen. On this one, I say if you're designing single family homes, a whole house fan is a prescriptive minimum. But and to do that, you would use the 3rd radio button for that first item, which says strong air velocity, motion up to 300 feet per minute for the whole house fan. A whole house fan is not required for multifamily housing, so I'm going to ignore the ventilation cooling. If you see this, I'm going to reset my radio buttons here. I'm going to ignore cooling from ventilation cooling. I'm going to keep my window shut, and there is no fan force ventilation, although there is a continuously operating bathroom fan. Onward to heating and cooling. Gas or electric, big conversation these days. If you're using a furnace, prescriptive minimum is 80% efficient furnace. We'll talk about going all electric in a little while, but all electric building, a heat pump will need to be 14 SEER with an HSPF, heating season performance factor of 8.2. Higher the number, the better. So for this one, I'm going to go with a code minimum 13 SEER and HSPF 7.7. Even though they fall short, heat again was built for a previous code cycle and hasn't been updated. They don't have funding from the CEC to do that. So we're going to go with this for now, and we'll adjust to the 2019 requirements in a little while. Overhangs on the windows, they're going to be fixed all year, so they're built into the architecture. We can explore closing of blinds a little bit later on, which is going to help with indoor temperatures. So on this one, I like, for the operable shading, I like the second radio button from the bottom, light Venetian blinds, close if the sun is on the window and somebody's in the room. Okay, so the next couple of screens, just scroll through them quickly in heat. These are about appliances. We can explore these later on. We also have solar systems, which we will explore later on. For now, leave as is solar ready area, second radio button, and no solar hot water heating. We can adjust the utility rates. This project, I'm doing it in Rancho Cucamonga, so I'm saying it's SCE territory. I'm going to leave these alone other than that. And you're going to land on the economic analysis screen. You don't have to do anything for this. You can, if you're doing some improvements, you want to see what your payback is going to be when measured against electricity savings. But let's move past them for now. And now the interview process is over. We're actually going to move on to the calculation. And scroll through the next couple screens until you land at this one. This is the home energy rating screen. This is the 2013 code, remember, that we're being compared against. And I've described my scheme 3 as 2019, current code cycle, prescriptive minimum. So we have 2 reference points for this, the 2019 energy code and zero net energy. Those are the 2 things that we want to keep our eyes on as architects. So before we make this final, let's go ahead and make some final adjustments to scheme 3 for the 2019 energy code. And to do that, here's what we're going to do. The glass type, the prescriptive minimum was U equals 0.030. The SHGC was 0.23. Solar heat gain coefficient, that number, the lower the number, the better. U values, same thing. We like low U's and low SHGCs for cooling environments. So we're going to make a slight adjustment here. So we're going to go to the advanced screen. We've been working in the basic screens in HEAD. So when you get really good at this, after you've done your first 2 or 3 projects in this, your first 2 or 3 sketches, you can go into the advanced screen. So what I want to do is start with Windows. So I click on the advanced screen, I go to Windows and Doors, and I get this this matrix here, and I can note, it notes here that the windows are listed as they're described in the radio buttons, 0.32 for my U value, 0.25 for SHGC. I want to adjust those down to 0.3 for my U value and my SHGC of 0.23. And by the way, I'm also going to adjust my door U value down to 0.2. So I'm going to change those values, just go ahead and type right in. And I'm going to adjust also the door value down to 0.2. On to walls. So the walls, the prescriptive minimum for our climate zone was 0.048. We selected 0.047. If I'm doing this anywhere but on this webinar, I'm going to leave the 0.047 alone. 1/1000th of a BTU per square foot is not going to make a loaded difference, but I want to get it right. I want to be exact. So I'm going to go to the advanced screens here, advanced, and you find the wall information on surface area. So I go into this screen, and there it is. Average U factor for the walls is 0.047. I'm going to change that to 0.048 to be precise, and I'm done. Heating and cooling. Okay, so we saw on the basic screen that the U value or the SEER rating for the HVAC system was 13 SEER and the HSPF was 7.7. But the new requirements, we're all getting used to the fact that the new energy code comes down and they reduce the energy budget. And they do that by making building envelopes more efficient and HVAC systems more efficient. So we are going with 14 SEER and 8.2 HSPF for the 2019 code. So we're going to go to advanced screens, HVAC systems. And when I get there, you can see the highlighted number there, 14. I've already changed that. And I'm going to change the HSPF to 8.2. And I'm done. Okay, let's take a look at hot water. It's required. It's not on the basic screens, but I do want to take a look at this, and I do want to talk about it. It is key to discussing all electric buildings these days. I go to advanced, and I go to water heater, and if you look at that, it's giving you options here, and it basically says number 1 is a gas water heater, number 2 is electric resistance, number 3 is propane, 4 is oil, instantaneous inline gas is 5, and electric is 6, and heat pump electric number 7. Ooh, I like that. So the 5 here is basically an instantaneous gas. We're going to go with that because actually that has an energy factor of 83. It's 83% efficient, 0.83. So that's the code minimum. We're going to go with that. We'll come back to water heater later on. And now I'm just about up to date. So we're going to hit recalculate. And I land here. So the 2019 scheme for this particular project has a HERS rating of 76. Okay. So we've now landed on our prescriptive minimum. This is what we want to use as the baseline for experimentation. So take a deep breath, and now that we have the baseline, we can start trading. This is where performance energy modeling comes into play, one element at a time. So the first thing that I'm going to do is create another scheme here. I'm going to go to library. I'm going to say copy scheme, and I'm going to copy scheme 3, which is my 2019 prescriptive minimum, and I'm going to give it a name that I remember. So I'm going to go with, you only get 24 characters here, so you got to be creative. I'm going no rigid installation plus the mini split. Okay, so I want to do that trade. I want to trade the rigid wall installation for my high efficiency HVAC system. So first thing I do is I copy the scheme, then I'm going to go back to the basic screen, select basic wall assemblies, select the radio button next to select to reload, and I'm going to go with 2x6 studs with R21 insulation, U equals 0.065. Okay, that's it. That's the one that I like to build. Okay, I don't need to do anything else on that screen. I don't need to go into the advanced screens at all. So this wall is going to perform 26 worse than the prescriptive minimum. So we're going to use ducted mini splits, which we talked about just a couple minutes ago. So we're going to go to the basic screen, then select heating and cooling. When I land on that screen, I'm going to select to reload any heating systems below that top radio button. And now what I'm going to do is best available heat pump, cooling, SEER of 20, HSP of 9.5. That's pretty damn close to those ducted mini splits, the Mitsubishis and the Fujitsus. Now that I've done that, I hit recalculate. That's the only thing I want to measure on this one, okay? And I'm going to land on this screen, and you can see that the trade here, I got rid of the rigid installation, $1.50 a square foot, and I've bought high efficiency, very high efficiency ducted mini splits for my units, and I have driven the number down. So I'm beating code at this point. So I would pull up my notebook and I would make a note saying, yes, we want to get rid of the rigid installation, go with ducted mini splits. That's my trade. That's the first thing you're going to tell your energy analyst, or if you're not doing the energy model yourself. Okay. Now here I mentioned this earlier. The mini splits have the variability in size. The Carrier First Co, the smallest system you had there was 1.5 tons. We want to go down as low as possible, and they make those ducted mini splits as small as 9,000 BTUs, 3/4 of a ton. So there's a really nice feature inside of HEAD that we can use. So we can click on evaluate at the very top, and then we can go to HVAC system sizing. And what this is going to do is a heat balance calculation for you for the hottest day of the year. It's going to find the sizing of your system. And that's the way that your mechanical engineer is going to size HVAC. They're going to find the peak load on the hottest day at that particular moment. And if I look at this, my HVAC sizing says for coolings, I need 6,206 BTUs per hour. And the sensible load for the coldest day, the heating loads are 2918, not a whole lot of heating load. But, now I'm back to the mini splits. 70, a rule of thumb for this, when you look at your HVAC systems, it says the rated capacity, nominal cooling is 9,000 BTUs, 12,000 BTUs, or 18,000 BTUs. The sensible capacity in that number is worth 70 to 75%. You've got to hold on to 25 to 30% for latent loads, humidity in the air. If you're cooking, if there are people in the unit, everybody's breathing. If you're in hotter climates that might be humid, then you need to hold on to some of that cooling capacity for getting rid of the humidity. And then everything else can be used to make the unit more comfortable. So if I go with 70% of my as my sensible capacity of that system, and I look at the smallest system, 9,000 BTUs per hour is my maximum times 0.7 equals 6,300, which is just bigger than that 6,200. So I like the 3/4 ton system here. I'm going to drive my mechanical engineer crazy because he wants to go with 1.5 tons. I'm going to show him my calculations, and we're going to haggle, and he's going to come around. I promise you. Okay, so the loads here could be managed by 9,000 BTU systems. So this is a great piece of information for your mechanical engineering discussions. I want to reduce the loads now. Okay, so I'm horse trading, but now I actually want to start hunting for other opportunities for saving energy. So one of the great areas here inside of HEAT, if you go to evaluate and you go to bar chart hourly, it's going to land on a screen that looks like this. And what it's going to tell you is the white bars are the cooling loads, the dark bars are the heating loads or the heat that's being put into your units, say from appliances. So if you look at this and you wanted to focus on cooling, you could see that the biggest culprit in this particular unit are the south-facing windows. So if you want to cut a little bit of energy, we can take a look at the south-facing units. The roof also has a considerable amount of energy coming through it. But let's take a closer look at this. Okay, so click on the 3D results. This is another great area to look at your loads. So select individual loads and then component loads. And now I want to look at the south-facing windows and doors. And this is where you're no longer reading tea leaves and HEAT. HEAT is going to give you three-dimensional graphs, which you can grab and rotate. And it's going to show you your annual loads month by month, average throughout the month over the course of the year. So this is a south-facing window. South-facing windows are typically saddle-shaped in the northern hemisphere because if you're in a climate like Los Angeles, 33 degrees north, at this time of year near the summer solstice, the sun is about 80 degrees over our heads. So less of that sun is hitting the window in the middle of the day. And if I put an overhang on it, I could really deepen that trough. Loads are higher in the winter, lower in the summer. South windows peak at 2.39 kBTUs per hour. So a lot of my load, maybe 20 to 25% of my heating load or cooling load is coming through the south-facing windows. So let's try to improve the south-facing windows by adding an overhang over the unshaded window. I did have one overhang over the big living room window, which is a porch above or a extension of the roof above. So I'm going to go library, copy scheme 4. I'm going to add an overhang. So I'm calling the scheme 4, which I like now, which was my rigid insulation for my HVAC system. I'm going to add an overhang to the unshaded window, and I'm going to go to the basic window design. And on that screen, I'm going to, before I get there, sorry, this is a detour. The 2030 palette, if we go back to that, again, linked from Climate Consultant, is going to, I'm going to find the solar shading swatch inside of the 2030 palette. It gives me some really good guidance. And it says for latitudes, we're looking at, for 33 degrees or so, we're looking at an overhang of 1/4 to 1/3 of the depth. If you want to just do this rule of thumb, that's a great way to start. So back to my screen here, I've copied it. It is scheme 4 plus add an overhang to the south-facing window, and I've got that 4x5 window, and I've decided that I'm going to add a 2.5-foot overhang. I've also had a large overhang over the living room window, over the porch that was there before, and now I'm going to click on recalculate. So this is a new iteration, and I'm seeing a slight reduction. It went from 73 to 72, not a whole lot because I already had one overhang there. If I didn't have any overhangs, I bet you the jump would be even more. Slight reduction in the EUI. And so these are the tests that we do, the trade-off tests that we do one at a time. So now what I'm going to do to save a little bit of time, I'm going to show the changes without any of the results. I do have some ground to cover here. I know We're growing short of time here. So my scheme 6 on this. The next scheme I want to do is add a little bit more roof insulation. So I'm going to go to an R38 roof, a U of E equals 0.024. So here I'm living on my advanced screen and surface area, changing that to 0.024. And scheme 7, what I'm going to do is add a cool roof. So on this one, advanced envelope screen, I'm going to change the SRI to 0.063, which is a decent cool roof, ages over time. We're looking at the 3-year age solar reflectance on this. Okay, I made that change. That's another scheme. And then I come back here, and you can see slowly this thing is inching down one at a time. And now the key is, in this discussion, I want to go all electric. So we started with a mixed fuel building with a instant hot gas water heater. I'm looking towards the 2022 energy code, which is really going to start to incentivize the all electric building. So I want to take a look at all electric. I'm going to copy scheme, and I'm going to say it's my last scheme, scheme number 7, plus HPWH, a heat pump water heater, all electric. Okay, that's my new name. Now I'm going to go to the advanced screen on the water heaters. And what I'm going to do here is select, in that first box is item number 7, heat pump water heater. And the next item down there is the energy factor. How efficient is that system? The most efficient gas-fired boiler or gas-fired water heater is probably going to be 97% efficient. 1 unit of energy in equals 0.97 units of energy out. The rest, the 3%, get lost in combustion up the flue or through the tank. The heat pump water heater has a energy factor of 3.5. The magic of the refrigeration cycle. 1 unit of energy in equals 3.5 units of energy out. So this is 350% efficient. Okay, onto the appliances. I want to go all electric, so heat defaults to a mixed fuel building. So I'm going to zero out the gas. I'm putting in an electric range. I found the data from the Energy Star website, 624 kWh per year for a typical residential range, and I'm going to zero out the therms for cooking. So I have a negative 29.1, which gets the gas to 0. And I'm doing the same thing for the dryer. I'm getting rid of the gas dryer, and I'm putting in an electric dryer. And again, I got that data from Energy Star, 800 kWh. Okay, so now I've got an all-electric building. I want to see how this thing is performing. Okay, so I go to my home energy rating, and just by making the conversion, my energy has gone down. I'll come back to that in just a little bit. Now that I've got an all-electric building, the last step for me is to add renewables. So renewables, the PV system. So I'm going to go to copy scheme. I'm going to call the new scheme 8 plus PV. Scheme 8, the all-electric building plus rooftop PV. What you can do inside of heat is add this, but before you do that, keep in mind the 2019 Energy Code has some requirements. You can do this calculation by hand if you need to. For any residential project at the start of the project, you have to understand how you're going to land the required amount of PV on your roof. So this calculation. This is a 572 square foot apartment in climate zone 9. So that's my equation. The size of the PV system is the conditioned floor area times column A divided by 1,000 plus the number of dwelling units times column B. Okay, so if I do that for my building here, I end up with a 1.72 kW PV system. It's a one bedroom apartment, so not a huge system here. So back to heat, onto the solar systems. What I'm doing here, basic solar systems, and I'm just going to say it's a 2 kW system just to land some PV panels on the roof. I hit recalculate, and I'm going to get my bar, and it is now approaching 0. It's got a EUI, energy use intensity, of 3 kBTUs per square foot. I can refine this on the advanced screen if I want to. You can do it too, but I'm pretty good with that approaching Z&E for now. Okay, so visualization with the renewable energy is kind of nice. Heat allows you to actually, it's going to deliver your PV panels onto the curb just like it does the windows, and you can click and drag those onto your building to see if you've got enough roof space. We like to lay our roof panels flat because we don't have to worry about shading of the solar panels one across the other. You can experiment with that a little bit. On the advanced screen for PV inside of HEAD, if you wanted to go for the flat panel, change the tilt to 0. It's at latitude right now, 33.9, so the most efficient for our climate, but we're gonna go to 0. And now it drops them in as flat. Okay, we're kind of zeroing in. How am I doing with my targets? My target was 6 kBTUs per square foot. If I want to hit the 2030 targets for this, I was at 3. So we hit our target. So I'm feeling pretty good about this. So for us with this, it's anytime you're selling this, and I'll get into this when we talk about our projects in just a second, it's about money. It's not necessarily about energy, but if you're going to sell your clients on this, you got to make the economic case for this. So the utility costs for this project that we just have designed, this particular unit, are going to be $80 per year or less. And I could probably get it to 0 if I wanted to. If I'm interested in carbon footprint here, which I am, I can also go to that pull down menu there, and you can change the variables here rather than looking at site energy kBTUs or dollars of energy for the whole project. Now I can go CO2 site production per square foot, and it's going to give me my my total CO2, which is 0.6 pounds per square foot of floor, which is great. I'm almost at carbon neutrality. I'm sure with another round of this, I could get there. Other things that you can do here, I like to use HEAD for window optimization. If you're going to do little studies for window shading, it's great. Passive cooling and night flushing, I put up a couple screenshots here that you can do. It allows you to actually determine the indoor temperature. If you design a building without any air conditioning, you can see how your building is doing and what each element that you might introduce might do to reduce the energy or the heating loads inside that, or the cooling loads inside of that space. For this, we're doing 12-day studies, which you have to do on the advanced screens, advanced climate and start date, and you can just find the month that you want to work in. This one I was working in July, so I think probably put down July 7/4 as the starting month, and it runs a 12-day analysis here, so you can really get precise on this. Okay, Z&E anywhere, not just Los Angeles. So there are great things you can do with HEAD to render. This is I taught this environmental controls at USC a couple years ago, and we used HEAD, and my students really went crazy. And you can see it's got some really nice rendering capabilities with this. It's not just the Shoebox. If you want to include this as a rendering tool to make your point to your client, you can do that. Small commercial, we did mention, Tom mentioned that this could be used for not just residential, but small commercial as well. Speed is the twin sister to HEAD. Speed is small building energy efficient design, and it has more capabilities, other occupancy types, and some really great schedules for understanding when systems are going to turn on and turn off depending on what kind of occupancy you have. I was toying with it, and I did a 10-story building with 78,000 square feet. So there's really no limitation, and we're trying to sketch here, right? And we're sketching, coming up with the conceptual pathway so you can have these conversations. Then you've got to get into your compliance energy model. Somebody's doing this, maybe you are doing this. This is Energy Pro, which is a building tree sort of function. It's not visual at all. You have to understand how your building goes together inside the context of a building tree. You make adjustments, unit by unit. Each one of those little condensers is a unit below it, and it's got information about the building envelope. Your report results in 2 steps here. Here's the key. Like, what is your report? This is your Title 24 report, whether it's a PERF 1 or a residential compliance model. What does it mean? How do you use it? How do you share the information? So what you've really got to do is find out, is the information in there? Does it match your design? Is your energy engineer, your energy consultant actually matching your design, or is he doing things that you're not anticipating? There are HERS measures which need to be field verified. Question is, how do you share the info, and who do you share this info, and do you share it at all? So the conceptual energy analysis, if you want to take the next step, if you want to start modeling, there are some tools out there. This is a plugin for SketchUp. Sapphire is out there, a really nice plugin for SketchUp that will give you sort of a throttle indicator showing you how you're doing and what the changes mean on your projects. I like it. It has a importer to G modeler, which is a little bit quirky. And it also has a way to export into Energy Pro, which is the building tree modeler. And like I said, not my first choice. ISV is something that I use. It allows for advanced visualization. It is really a design tool. It has just been approved for compliance modeling for non-residential buildings in the 2019 code using the IES Apache engine. It was previously approved using the CBEC COM, which is a state of California approved engine. A little bit of a steeper learning curve with ISV, but man, once you get there, it's great. And then if you're doing the same type of project over and over again, it's easy to develop standards and templates. That shoebox analysis that we just did is that unit right there, taken right out of ISVE. This is some visualizations that I did. What I like about ISVE is you can see the constructions. Am I getting all the constructions correctly? I can't do this in a tool, building tree tool. I can do thermal templates. I can do zone groups. I can run HVAC load calcs. And like I said, you can run Title 24 energy modeling here. Coming soon in ISV. It's actually here, it was approved last month by the CEC. Okay, and these are, again, visualization where I was looking at the HVAC load sizing. So if you want to have a conversation with your mechanical engineer about his sizing, you can do a quick visualization in ISVE, and you start negotiating or haggling with your mechanical engineer. Okay, run manual JS&D is running manual JS&D is a requirement for Lead for Homes, which we use. I use other software tools for that, but the J and the S are for sizing. So this is great for IES, and heat even is really good for sizing. We also like to coordinate our max PV design. The last couple slides I'll show you here, and I'll power through these, are really related to the work that we do. This particular shot is the Swanton Curve, which says that every time that the global capacity for fabricating photovoltaic panels, the manufacturing capacity doubles, the price of PV drops by 20%. It's a really interesting academic graph, but we get to buy at National Core, we're buying solar on every one of our projects, and we get to see these costs going down, and they have gone down dramatically. 5 years ago, it was probably $350 a watt installed. We just bought a project out in San Bernardino for less than $2 a watt. And what that allows us to do is land a whole lot of renewable energy on our projects. This is San Ysidro Senior Village, 51 units of special needs housing down in San Diego. This is Day Creek Villas. It's 410 kW on a 140 unit senior project in Rancho Cucamonga. Zero net energy electric. It's a mixed fuel building. It has a 97% boiler. And what I end up doing a lot as an energy analyst, when I'm putting my architecture hat aside and looking at energy, I'm looking at operational economics. So I want to optimize the size of that PV panel, and I want to figure out how much money we can save by dropping renewable energy on our projects. So this is San Ysidro Senior Village. We're actually saving on this one by dropping the rooftop solar about $47,000 a year. And what does that look like over time for San Ysidro Senior Village over 30 years? That's nearly $2 million. So we're building affordable housing, serviced enhanced affordable housing. We can certainly do a lot with that. Last stop, I promise I'll make this short so we can answer a couple questions. The DDX, the AIA DDX, we measure, cut, and report. So this is, we are continuing to meet our obligations and commitments to the AIA 2030 commitment. These are our recent projects inside the AIA DDX. This is one we just finished, Vista Verde all electric. It's nearly all electric. It has one gas meter that services the community laundry room. I was chicken and didn't want to go with electric resistance water heaters or electric resistance dryers, but it has heat pump water heaters. It has a huge PV footprint. And most importantly for us, we hit our targets by a long shot. Our target was 16 kBTUs per square foot. We're at 2. And I think that this one could actually get to 0, meaning it would be carbon neutral. The future, I believe, is really going to be all electric. And what do we do with those savings? We infuse them into our projects and buy more resident services and things like that. So that was my tour through conceptual energy analysis, and I know we are getting short on time on this. So Tom, do we have any questions?
We have one from Megan, and maybe part of it got answered through your modeling descriptions, but she is asking specifically about, is there a way to model a trom wall or a mass wall?
Yes, Megan, there is. And you can actually do this inside of HEAD. On the advanced screens, you can actually go into the advanced screen, and there's one called thermal mass. And if you put that thermal mass inside of your building, then you can actually model it. Can you measure the solar gain effects of that in HEAD? Probably not. But if you wanted to do something like that, you probably want to move into a more advanced tool like something like IES. You would definitely be able to place the trom wall inside of a glazed opening, and then you could describe all the elements and you could see what's going to happen to your indoor air temperatures. Great question.
The other one is about modeling a light well, and I think, you know, maybe you did sort of show it because your last model was like a courtyard type building, but she's saying, is there a way to model a light well or an interior open courtyard that has an opaque wall very close to the window? This happens a lot with detached ADUs next to existing walls.
Yep.
What do you think?
Yeah. So for that one, again, I'd say advanced tools on that one, if you can, Megan. Sapphira has some really nice daylight visualization plugins to it, you know, which you can model your energy performance. You can also do some daylighting. ISVE will allow you to do daylight simulation. You know, it will use the lumen method, which is really straightforward, but it will also allow you to do things like radiance. You know, so there are other tools out there. You could start with andrewmarsh.com, go to Andrew Marsh's tools and see if there's anything that you can build inside of his online tools, which are also free. His tools are fabulous.
So, you know, Tim was nice enough to leave his email there. So if others have questions they think of afterwards, you can email him directly. Otherwise, a big thank you again to Tim for his excellent presentation. If you've made it this far, AIA California staff will submit you for AIA CE credit. It should appear on your transcript in a few weeks. As always, more resources and tools can be found on AIA California's website, which is www.aiacalifornia.org/climate-action. More details on the 2021 Climate Action webinar series will be shared with you via email. Thanks again for joining us today, and we'll see you at our next Climate Action webinar. Thanks, everybody.